All right, so today we're doing 7.3, which is on assessing normality. And we're going to do 8.1. So we're in Math 21. I don't know what day it is. Done writing that shit down. So picture back to that bear data set. Picture the bear data set. In fact, we're going to work with it in a second. We don't know if the bears follow a normal distribution in length or weight. We assume they do, like humans do. We would say height and weight rather than length. But we have most people are around an average height. There are a few people that are fucking gigantic basketball players, and there are a few people that are really like short. And a common career for them is actually horse jockey, race jockey, because the lighter you are, the smaller you are, the lighter you are, the faster the horse can go. And they can make some good money at that. But it's usually for the most people are in the middle. We assume the bears are, but we don't know. That's what this section is about. So how do we, that's our goal. Can we determine if the population behind a data set follows a normal distribution? And the answer is yes. So this will come in one of two ways. Option one, if we have just the observed values. We can do a graph, and we're going to choose QQ plot. I like QQ. I like the name QQ. I don't know why they call it QQ, but in like online games, like where there's combat and shit, QQ means go cry more, noob. Looks like two eyes with little teardrops coming out. So QQ means you quit being a crybaby. Go cry about it. I like QQ. All right. So what you'll do here, once you've done that, you will add correlation stats. There will be two boxes. We'll do this in a second. Add correlation stats and check mark normal quantiles on y-axis. Option two, if you're given z-scores. If you're given z-scores, you can just do stats, regression, simple linear. both of these, you will be able to find R. You will get R, the correlation statistic. And just like we did with chapter 4, we are going to compare the absolute value versus CV, the critical value. Critical value from it's table 6 in that file. It says critical value for, I think, normal probability plots. And if R is greater than CV, the data is approximately normal. That's what you're looking for. And that's why we call it assessing normality. We can say the data is following approximately a normal distribution.
Fine, it says, it, is that,
The absolute value of R
oh,
is greater than critical value. That table open. And I'm gonna load up the data for the bears. I'm gonna go take a look at the bears. All right. So, does anyone need this up longer? Just trying to make sure everybody had a chance to write it down, but. All right, by your silence, I will take that as a no. So we did the data set for the bears before. This was 4_3_7. You've seen them. We're gonna come over and look at them. The bears. let's say 4_3, maybe it's 4_2. I think that's what it was. Yep, there they are. There's my bears. So these do not have a z-score calculated. So what we're going to do is our QQ plot. Graph, QQ plot. We can look at them both. And these are the two boxes you wanted to add: correlation statistics and normal quantiles. And they make a line with dots. And we saw a line with the dots with these guys before. Let's go look at it real quick. So that doesn't have the line. So that's the kind of graph we had before. So this is a different graph. It's definitely a different graph. Here we have length versus weight, which is what we did before. But what we have on our current graph is we have length versus normal quantile. Notice it goes from -2 to 2 on this y-axis. These are z-scores. So it's got z-scores along the axis here, and the dots are all relatively close to the line. This was for length. And if we look at weight, weight does something similar. Most of the dots are pretty close to the line. In fact, it doesn't even go down to -2 here. At the top, we see the correlation stat. So the length has 0.963. And the weight has 0.967. These are our R scores. These are R. If we come over and look at our file, we're doing the critical values for normal probability plots. And for n equals 12, we need it bigger than 0.928. So 0.928 is our critical value here. I got it from the table. I'm going to go back to the paper now so you can see what I'm writing. I don't need the absolute value because they're already positive. In both cases, it's greater than. So the bear's length and width normally distributed. What?
Wait,
That's dumb. Wait. We always say length and width together for rectangles, so
You were saying on the QQ plot to check the boxes, and say correlation stat, and what was the other one?
And supposed to tell me if I went too fast.
Well, no, I was trying to get it if you're reading.
Check mark normal quantiles on the y-axis.
Normal quantiles.
Two cubic inches, period. And divide pounds by cubic inches.
Find for the CV, you go to on Canvas files, stats, and under where else?
It's in the files. They're going to files, useful handouts, stats. And you'll see that one. It's one we did on Wednesday too.
You take it.
All right. So let's take a look at another one. We're gonna do one from 7.3. If you're working along on the computer, you can access it. It's 7.3.4. This is on chocolate chips in a bag. Kind of like a couple of your problems on the midterm. I'm not going to write down the data because there are 40 data values. So we're not going to write down the data. But you can access it from that list. We're going to do this check here. So you do it the same way. You click on the data sets. Takes you over here. Now I'm going to just select SAP chapter 7. So you'll see we got 40 rows of chips. So we're going to do stats. Not stats, graph QQ plot. Chips per bag, and we will add the correlation statistic in normal quantiles. Look at how close they match a line here. That's pretty good. We can see the correlation statistic at the top says correlation, if I spell it right, is 0.986. And we can go look, and we can see that n equals 40 from the list. There's 40 rows. So we need to get the critical value for 40 rows. And if we look at the table here, it only goes up to 30. So if it only goes up to 30, just use the 1 for 30. If you need more than 30, just use 30. So 30 is 0.960. So I'm using that one. The correlation stat is greater than it. So the chocolate chips are approximately normally distributed. All right. That's chapter 7.3. It's fairly straightforward. Again, not on your final. Let's take a look at chapter 8. Chapter 8 is on sampling distributions. And 8.1 is on sample means. So let's motivate this idea. This semester I only have 2 stats classes, but I had 3 stats classes one semester. And for each, the sample mean was different. Since the sample mean is different, Not the fact that it is different, but the sense the sample mean can be different. It is a random variable. This is something we talked about way back in chapter 2 or 3, some shit like that. And since it's a random variable, it has a it has a probability distribution. So I could find the mean of those means, those 3 classes. Of the 3 different class averages. Kind of like the mean of the sample. Mean of the sample means. It's like crazy talk right there. Mean of the sample means. If we do, this has a really neat effect. This sort of eliminates outliers. Not eliminates, but eliminates the effect of outliers. Because one outlier in a class will adjust the mean in there a little bit. But like when I do it, average it with every other class, it kind of like takes it away. You'll see we're going to do this with IQ tests, simulated IQ test scores in a little bit, and you'll see what I'm talking about. But we have a couple things that come from this. So the mean of the sample means, mu of x bar. That's my mean of sample means right there. That should be the same as the mean of the population. The overall population. What changes, the one that's different is the standard deviation. The standard deviation of the sample means should be the standard deviation of the population divided by the square root of n, where n is the number of sample groups. Not the number that's in each group, but the number of groups. So we could have like 10,000 people in each group, but if we're only looking at 25 groups, n is 25. Doesn't matter how many people are in each group, it's just the number of groups here. And you might see it mentioned something like standard mean of the error. This is the standard mean of the error. Alright, so let's look at an example. Does anyone need that longer? Gotta give a little gap there. Let's look at, we're gonna start off with the IQ test. The IQ test is a normal distribution. We already know that. It has a mean of 100 and a standard deviation of 15. So if you had like 9 different groups, the mean of it should be still 100, but the standard deviation is going to be the 15 divided by the square root of 9, which is 5. Why don't you guys try doing it with 25 groups? See what you come up with. You know, 30 seconds. Good to see you this weekend.
Yeah, I overslept severely.
It's all good. Me and Angel were grinding it out.
I'm gonna definitely be here on Sunday though.
Oh, this weekend, I'm not gonna be there.
Oh, okay.
Wisdom teeth are coming out Friday and presumably like the first 2, like 2 days later is like one of the worst days. I'm hoping I'm good to go by Monday night. My first class is Monday night at 3.
Oh,
So I'm hoping like a 3-day window is enough that I can come in.
we're talking gauze on the cheeks and maybe a prescription for Percocet. That's what
Right.
they gave me when I got my dent.
I know they'll give me a prescription. They recommend trying ibuprofen first. Fuck all that. Give me the narcotics.
Yeah.
I do ibuprofen all the time. Fucking, you're gonna drill into my whatever the hell they do. Now, give me the good shit. It's only a couple days worth. You're not gonna get addicted in a couple days. All right, so if you do it here, the mu should be the same. The standard deviation is gonna be 15 over the square root of 25, which is 15 over 5, which is 3. So this is kind of neat. StatCrunch allows you to simulate some of this shit. StatCrunch allows simulations. You don't need to do it, but I'm going to tell you how to do it. So we're going to simulate IQ testing. If you go data, simulate, it gives you a bunch of different options. And what I did for the following was normal. I told it I wanted 2,000 rows. And I believe I had 25 columns listed. And then you also have to enter. Mu equals 100, standard deviation is 15. Gotta give it the normal distribution for the IQ test. After that, you can start simulating these groups. You can generate sample groups. And calculating the mean among the groups. By doing the following. I did stats, summary stats, rows. Normally we do columns, but I did rows here, and I said mean, do the mean on it, and store it in the data table. And so it'll make a new column for it. And then after you do that, you do stats, summary stats, columns. And find the mean of that stored row. I think I told you something wrong here. N is the sample size in a group. Not number of groups. Because usually you're just gonna have one. You're gonna have one thing and you're gonna look at it as a specific group. I'm gonna do mean of the stored row. I'm also gonna do standard deviation. I'm gonna show you that the standard deviation goes down. It will no longer be 15. You guys ready? All right, so this simulates a normal distribution. I did data simulate normal. I took out rows and columns and I told the mean and standard deviation. And I said, do not round, or I said number of decimal places equals 0. If you don't do the number of decimal places equals 0, it'll give you fucking a bunch of decimals. It's fucking lame. We don't want decimals on this, so that's what I did. That's what I got here. We can see that there are 25 rows with the normal distribution. And, oh shit, I didn't do 2,000, I did 20,000. My bad. I went gung ho. So. Mean 9, where it says mean 9, this column right here, it took the mean of the first 9 rows. And I'll show you that right here real quick how I did it. That was stats, summary stats, rows. And I just selected the 9 rows. Or 9 columns. And I told it I wanted the mean. And I said store in data table. And we can see this is the new data. You can compare the two and you can see that they match up. So it takes the first 9 entries of each group, and we're saying that's what the mean is for that group of people. Then there's 20,000 groups. 20,000 groups of 9 people. I'm going to delete that. I just did that to show it to you. So then and I did it for the 25 also. Did the same thing for the 25. I just selected all the rows, all the columns. And then we're going to do stats, summary stats, columns. And we're just going to do the 2 that we did there. And we're going to look at mean and standard deviation. And we can see that the mean for both is really, really close to 100, which is the population mean. And just like we predicted on paper, if you divide 15 by the square root of 9, you get 5. If you divide 15 by the square root of 25, you get 3. That's what the standard deviations are for these. I'm going to show that graphically, kind of like what's going on here. Because this is like helpful to see. The IQ distribution is like that. We had 100 in the middle here. This is 115. And this is 85. And we have more clicks going outward. This is mu equals 100, standard deviation equals 15. Now, by doing 25 groups, we're down to, let's do the 9. Let's do 9 groups. For the 9 groups, we're still along the 100 here, but each deviation goes to the right 5. So 115 is actually 3 deviations for the mu equals 100, standard deviation equals 5. So this graph, and I'm not going to do it justice, it's really fucking tall there. It's going to go like that. It's really tall and narrow. I wish I'd given myself more room on paper to make it taller and less like that, a little bit more looking like a normal distribution. But now all the outliers, like Albert Einstein's way the fuck over here. Albert. His score is now been averaged in, and now rather than having these big deviations, we have very little spread. From the mean. The Einsteins get averaged out. In fact, the only way they will still have an impact, they can have an impact if whole groups have nothing but outliers? Like maybe if we did our sampling at a fucking Mensa meeting or some shit like that. The fucking smart people of the world. The super, super smart people, I should say. I'd like to think I'm pretty smart, but I'm not in Mensa. I don't qualify for Mensa. Yet I've studied astrophysics and all sorts. I can unlock the secrets of the goddamn universe. If I took some chemistry and shit like that, I could simulate being God. Try to create life on Earth. I could try to do that without biology. I don't know now. That's a little far. That's a little blasphemous. Maybe I'll take that back.
You can do it.
I don't want to offend anybody in here.
You can do it with bugs.
I mean, just creating life from nothing. I'm not talking about mutating bugs and shit. That's right. All right, so. And if we look at, let me come back over. Wait, does anyone need it? Oh yeah, some people are still writing. I want to look at our results again and look at like the histograms. So you can see a histogram of some of the shit. All right. So I'm going to do graph, histogram. I'll choose like I don't know, pick column number 4 and do the 2 like that. So this is just the group number 4, regular distribution. So it's got a normal distribution, right? Notice that it goes from 100 to 160. We can see that, and that the height is only around 2,500. When we switch to a mean of 9, it shoots up to higher. And now it's not as wide. This is what I was trying to say earlier. Like it goes up to 115 is about 3 deviations. And look, this is where the graph tapers off. Going 3 deviations either direction, that's where it tapers off. Like a normal distribution. If we look at the one for 25, it tapers off even before that. It only goes out to like 109. Still a normal, so it's oddly enough, the frequency is lower here, but there's more columns in the middle. So I guess it's the way they're breaking the columns up. Either way, it's a normal distribution that's got less spread. Well, we started off with the normal distribution. So like, why shouldn't we end up with a normal distribution when we're done? Check this out. I did the same thing with dice rolls. Roll a 6-sided die and record the number. So you should get about the same number of 1s, 2s, 3s, 4s, 5s, and 6s. It's called a uniform distribution. If we look at a histogram of this, something's wrong with this distribution. I don't know what it is, but it's still definitely not normal. The middle ones are all the same height, but for some reason, why has it got only 1 up to 1? Let's try this. Edit. Start at 1 and do a width of 1. Well, that didn't help. All it did is made it, what? It just made it look fat. What happened? It's not even a histogram here. Histogram, the bars are supposed to touch. What is this piece of shit doing? It just made the bars go plump up. They're fucking thicker now. Still the same height issue. They should be all roughly the same height, but this is definitely not a normal distribution. It's flat. For the middle ones, it's flat. So we do the same thing here. Oh, I did 100 rows this time, or columns this time. We can look at the stats, summary stats of the columns. Oh wait, that's not what I want to show you. Let's look at the histograms of the final results. Once you average out 5 groups, or 5 per group, 10 per group, 25 per group, 50 per group. 5 per group looks like that. I don't know, this makes it look funny. 10 per group, now it's starting to look a little bit more like a normal distribution. 25 per group, now it looks a shitload like a normal distribution, right? I'd say that's a normal distribution looking at it. And that's a normal distribution as well. When n gets high enough, it starts to look like a normal distribution. Low values n, that didn't really look like it. Sort of looks like it. Still a lot of high values in the middle that are around the same height here. As soon as we get higher though, it starts to look definitely like a bell curve. But we didn't start off with anything at all that looked like a bell curve. That leads us to a very, very important theorem in statistics. And maybe I should do a new page for this one. It's called the central limit theorem. Regardless of the shape of the underlying distribution, the sampling distribution of the sample mean is approximately normal for large enough n. Now, what's considered large enough n? There's different values listed in different books. Some books say n greater than 30. Others say n greater than 40. I think if you stick with the higher one, you're definitely good. But like the critical value table only goes up to n equals 30. So like you're pretty good with either one. If you're in the 30 plus range, you're probably good. In fact, we saw from the uniform distribution n equal 25 looked good. And that's from a uniform distribution. Ah, I did these earlier and it didn't say the answers. The fuck? I didn't click save or something. What ones do I want to do with you guys here today? We'll take a look at question number 1 and 3. I'm gonna do some homework problems with you. I'll just wait till you guys are done writing this down. We'll look at question number 1 and question number 3. My numbers will probably differ from yours, but I'll write down what I got and we'll show you how to do them. Because applying this shit is, it's not that bad once you like really like figure out what you need to do. But if you don't see one of them done, you're like, I don't know what the hell's going on. Angels, I hope that's a energy drink. It's not? You fucking chugging a beer?
No, it's,
Liquid death, Jesus Christ.
sparkling water.
There's no way in hell there's a sparkling water called liquid death.
Oh, they started off selling just normal water. It's in a aluminum can, it's not in plastic, because plastic does too much waste and it's hard to recycle. So that's their selling point,
Why is it called liquid death if it's water?
just to stand out. I mean, it got you all, so.
I would just do it because it was a can. I didn't even see the name until you fucking rotated it.
Sparkling.
I'm like, energy drink at 6 o'clock at night is fucking psychopath. That's somebody that's got to work the graveyard shift, you know? Which is a fun shift if you've never done it. We're gonna have midnight to 8 AM and if I like Taco Bell or some shit like that. Very rarely you have like a boss, it's like you and another employee, you guys like self-manage yourself. Good times. Except on Friday and Saturday night, then you're like, fuck me. It was like fucking 12 o'clock, everybody's like done fucking, or you get like that 11 to like 2 AM. And then like 2 AM, like everybody's leaving the fucking bar at 2 and like, I want to be a burrito. And, can you speak English, please? Stop slurring a little bit. I don't know what you're saying. Good times. I had a lot of fun.
They got a coffee company out of New York called Death Wish. You ever heard of it?
Mhm.
It's got Skull Crossbones on it.
I've seen some crazy ones for coffee, but like water seems ridiculous.
Yeah.
That's just,
They have like tea, stuff, sparkling water, regular water.
okay. Do they have energy drinks too?
No, their teas have like microdose caffeine, like 100 milligrams.
Whoever says microdose for caffeine. Microdose is generally another topic here, buddy.
I mean, you microdose caffeine when you drink sodas every day. It has like 55 milligrams.
I thought sodas have like regular, like almost as much as a cup of coffee.
I mean, it depends on.
You drink a diet soda or some shit? I don't know. Oh god, I had a good time working graveyard shifts. That was good stuff. Fun fact. Because we're gonna be done in like less than 10 minutes, 15 minutes. When I was, I don't know, 18 to 20, I worked at Taco Bell, did the graveyard shift. And I worked with someone that was like 35. This was in 1992 to 94. Most of you weren't alive, but those of you that were know the kind of music that was out. It was not shit like Stand By Me. It was like other shit. So like he liked to listen to the classics, old music. And so like he put on, we'd change, me and the guy would change what station we'd listen to each night. And when he went up first, he's like, this is song, yeah, I'm gonna request Stand By Me. It was midnight, no one's up at midnight. You can call in and request shit from the radio stations all the time. It's fucking great. We call in every hour. And he's like, do you know Stand By Me? I'm like, no. He's like, you don't know Stand By Me? I'm fucking 18. I'm like, no. He's like, all right, we're gonna give you an education in classic music, not classical, like classic music, like good old music, oldies music. And I listen to oldies like so much, like that's one of my favorite stations. Now I know like all the 50s music and 60s music, I can sing that shit along. That's your fun fact. I was not born anywhere near that timeline. You know some of them because you told me you sing the Beatles. But you probably don't know as many as I do.
Oh, good. By the way, on average, a Coke can has 34 milligrams of caffeine in it,
And how much does coffee have?
3 to 4 times that much. Like a
Really?
normal cup of coffee that's 12 ounces is 3 to 4.
A normal cup is like 100 to 120, something like that. I wouldn't call a quarter or a third microdosing though.
Well, microdosing is anything that's below, technically, like below a half gram.
Has anyone ever heard microdosing used in context with caffeine?
I've never even heard that word before.
Oh my, really?
In your
Sounds like a
iced
chemical
tea as
deal.
well, you use
Yeah, microdosing is what you do with like psilocybin and shit like that. Like acid, dropping acid, like doing just a little bit of acid rather than like a lot of like a regular dose of acid. Where you just get a slight hallucinogenic feeling, but it's not enough to like trip balls. It's really what they say.
With antidepressants, it'll start you at 5 milligrams, it's technically a microdose. It's an extremely small dose.
Who here drinks 1 can of soda? I don't see any hands going up. So no one microdoses on soda. You're drinking 3 or 4 fucking cans, it's the same thing.
Yeah.
Alright. Question number 1. I think everyone had enough time to write that shit down, listening to my stupid tale of Taco Bell. Question number 1, I'll throw it up on the screen in a second. It said, well, shit, I'll do it now and I'll keep writing. It says determine mu of x and sigma x given mu equals 87, sigma equals 12, and n equals 36. It might be easier to read with my big ass handwriting. That was good times. One of the guys I work with called me Rerun. From What's Happening or some shit like that. Because Rerun never shut up. And he called me Rerun. He even bought me a Bible that said it had my name like embossed on it. David Rerun Jones. He converted me for a little while. I became a Christian for a little while. Actually, I was a Christian for a long while. All right. So, assuming you have that written down, mu of x is the same thing as mu of the population, which in this case is 87. Sigma x is sigma of the population over the square root of n. This is 12 divided by the square root of 36. Square root of 36 is 6, and this becomes 2. So these are the 2 answers I'm entering on that problem. This is just it's like a warming you up to the idea of this stuff. And then we'll do a word problem that uses this shit next. So question number 3 actually does a word problem. They don't actually tell us what the word problem is about. But they say a simple random sample of n equals 12. Is obtained from a population with mu equals 62 and sigma equals 16. And then it asks, first thing it asks is, What must be true to use a normal probability model? So, one of the following must be true. It either needs to be one needs to be a normal distribution. Or two, n must be large enough. One or two. You don't need both. Which is funny because when I did the morning class, they had n equals 42. And 42 met the criteria for n is large enough. They had a different answer than I have here. N is not large enough with n equals 12. So we're going to require a normal distribution. And I'll show you the options they give you, so you'll see. But I want you to know that your problem may be different. It may be that n is large enough. Because I already know that it asked more than one version of this with different answers. Waiting for everybody to finish. Does anyone need this up longer? Okay. Good now? Okay. So it says option A, they must be normally distributed and the sample size must be large. It doesn't need to be both. It says since the sample size is large enough, the population distribution does not need to be normal. For the n equals 42 case, that was the good choice. C, there are no requirements, which is false. There are requirements. D, since we didn't have a large enough sample, our population must be normally distributed. And now it says, assuming the normal model can be used, like so, maybe that it is a normal distributed group, what can we say about the sampling distribution for the mean? It should be the same. The mean should be the same. The standard deviation should be the standard deviation 16 divided by the square root of n. We are looking for C here. So I'll write this down on the paper where you can see a little bit better. So for us, we did that one, not that one. So then it asks, what can we use? Mu of x is going to be the same as the population, which is 62. Sigma x bar is going to be 16 divided by the square root of 12, which is the population standard deviation divided by the square root of n. Now, I don't know what that value is, but we need it for the next spot. Because parts B and C ask the following stuff. I'm going to write down a value for that in a second. B says, what's the probability that X bar is less than 65.6? And C says, what's the probability that X bar is greater than or equal to 63.8? We were given these numbers up here, but if you use these numbers, you're going to get the wrong answer. The mu is fine. we're gonna use mu equals 62. But for standard deviation, 16 divided by the square root of 12. I'm going to write down as many decimal places as my calculator shows. And that way my answer will have as good a rounding. I can't fuck up the rounding because I was lazy on the calculator work. At this point, it said, assume it's normal, assume you can use a normal model. If you can use a normal model, we can do stats calculators normal. I am going to use mu equals 62 and standard deviation is 4.618802.154. Not sigma equals 16 like was given. Yeah. Saw him fall back in like slow motion. I was about to say something like they're already gone. There's no way he's gonna catch it. Have you ever done this with your glasses and couldn't find your fucking glasses? It only really matters to people that use them for sight. Like everybody looks a little bit blurry right now. I can read my text. I have a stigmatism, which allows me to see better certain ranges. But like it affects people with prescriptions more, but usually the people you hear bitching about it is their sunglasses. Because the people who wear prescriptions don't do this. We don't do that. Just as like we don't. You either keep them on your face or you get those old granny things where you hang them around your neck. Because if you do this, your hair has oils on them. Like you naturally produce oil and then it gets on your glasses and then you gotta fucking clean them. Which means I shouldn't have done this myself. All right, looks like everybody's done writing. We're gonna come back to the PC. All the little jibber jabber I like to do to give people time. Do not, okay, hold on. Do not click on this shit. Do not use this. This is the way we used to have to do it. We used to have to turn it into a Z-score. And then we had to do this shit. Don't. This is a fucking godforsaken table. Do not do this shit. If you do it by hand, I'm not going to help you because you deserve the suffering you asked for. You want to suffer, you suffer on your own. I'm not going to suffer with you. If you want help, I will help you and I'll show you how to do the stack crunch way. I just opened it. You can do get more help, stack crunch. God damn it. What the fuck? Why can't I?
That's me.
Oh, there we go. I'm fucking getting pissed now. Stats calculator is normal. Right? I feel your pain. My stats class, I didn't get this shit. I had to do this shit by hand.
I'd rather do it.
You say that now. No, you wouldn't. This is like learning Excel, basically. So our mean was 62. And my standard deviation was 4.618802.154. Like we let everybody use their notes for the midterm. So you didn't need to know the stat crunch. You could have had the shit written down how to do it. And the final, I'm gonna do it all for you. So your grade is not dependent on your ability to use stat crunch in this class. We were doing less than 65.6. It says less than, we don't have that option because on the normal distribution, the equal portion is actually 0. It's a rectangle of 0 width. I click compute. How many decimal places does it want? It wants 4 decimal places. We're not gonna drive our fucking instructor crazy and only enter 3. We're gonna put all 4. Fucking grading mid, oh my God. I had so many things I had to correct for people not rounding wrong. They just rounded to the wrong damn decimal place. Like it says round to 4, they'd be like, nope, I'm gonna do 2. Or if I said 1, no, I'm gonna do 3. Like just there's no fucking path or metric to, or I don't know. It was not consistent. They would change throughout the fucking problems. They would round to a different decimal place on each problem. And a lot of the times it wasn't what was asked. It's trying to fucking drive me crazy. Give me extra work to review. You ended up losing points for it. But if it was like worth 2 points and I saw you did that, I gave you like 1.9. So I gave you credit back because you did everything right except follow fucking instructions. All right, we're gonna check that answer. Excellent. Notice this was the 7821. If I used 16 here, which was the original standard deviation, I get 0.5890, which is not 0.7821. You would get it wrong and you're gonna be like, I don't understand. I put it in like you said. You have to divide by the square root of n first. Okay? Then it'll ask you for, this says greater than 63.8. Make sure your sign matches. They changed it up on us. Wow, 2 of them that I don't need to round up. Oh, you're right, I didn't change back. Ah, there you go. Showed you, it's gonna tell you wrong. And then I come over here, and that was total accident. I'd like to say that was planned, but it was not. Try this again. Now I gotta round up. So round the 3 up to a 4. There we go. That's all I got. Get the fuck out. GTFO.